Good morning students. So today I am going to discuss about similar triangles. So let's discuss what is similar triangle, what is similar shape. So basically you have two figures of similar shape but different size are called similar shapes or similar triangles. For example, if you are taking a picture of your dog and if you are going to zoom in or zoom out, that dog looks similar to each other. It doesn't happen that if you are going to zoom a dog, it will look like an elephant. Why it is happening? Because if you are zooming at the picture, each and every part of that picture is getting enlarged by same proportion or same ratio. That is the example of similar shape. One more example you can take. Three people are watching this lecture on three different gadgets. Suppose if you are watching on the mobile, another is watching on tablet and another is watching on television set. In all the cases, that picture looks similar. This lecture looks similar to each other. How? In case of mobile, if ratio is 2:1, then in case of laptop, it is going to be 4:2. In case of television, it is going to be 6:3. So what can you see from here? You can see that ratio of sides is 1/2. This is also 2/4 and this is 3/6. So basically all ratios are 1/2, 1/2 and 1/2. This is what happens whenever you are zooming a picture in your mobile or in your laptop. So basically we can say that these all three are similar to each other. Okay. Similarly, we can take another example of similarity. If you have a triangle, let's say this triangle is 3, 4 and 5. Okay. You have another triangle in, let's say this is 6, 8 and 10. If you are going to take ratio of this side and this side, ratio of this side and this side, ratio of this side and this side, we are going to get 3/6, 5/10 and 4/8, which is again 1:2. So basically both the triangles have different size but same shape because side lengths are in proportionality. They are in proportion. Basically one length is double, then other is also double. So it is like enlarging an object, each and every part of an object, like you are doing in your mobile or in your laptop. Okay, I hope you got what is similarity basically. So sometimes a question is given. If I am giving you a question A, B, C, length is 3, 4 and 5. I am giving another triangle. This is P, Q, R. So this length is, let's suppose this length is 9, this is 15 and this is 12. I'll give you 4 options to answer. I'll ask triangle ABC. This is symbol of similarity. Is similar to triangle PQR. This is the first option. Similarly, this triangle ABC is similar to triangle QPR. Triangle ABC is similar to triangle RQP. If I am asking this question to you, which of the following is correct, then you have to look at the figure. Which side is proportional to which side? In this diagram, we can say that AB divided by PQ is 3/9. Similarly, we can say that BC divided by QR is 4/12. We can say that AC divided by PR is 5/15. So in all the cases I am getting 1/3, 1/3 and 1/3. So from there I can conclude that corresponding to A, point P is there, corresponding to B point you have Q, corresponding to C you have point R. It means triangle A should be first, then P should be first, B should be first, then Q should be first, and C should be first, then R should be first. So from there we can conclude that both the triangles are similar to each other. But if someone is saying, sir, triangle ABC and QPR is similar, now there is a very big mistake here. If you are writing AB upon QP, you are writing BC upon PR, you can see that these and these ratios are not equal to each other. If these ratios are not equal, it means these sides are not proportional to each other. Okay, so I hope you understood what is similar triangle basically. So you need to understand sides should be proportional, so we have to write corresponding points. Okay, you have studied in class 9 about CPCT. I hope you have studied. What is CPCT? Corresponding part of a congruent triangle. Here we have to study CEST, corresponding part of a similar triangle. Like in this triangle, A is corresponding to A, we have point P, corresponding to B, we have point Q, and corresponding to C, we have point R. So both triangles are similar to each other. So I hope you understood. Every time you must check, you must write corresponding sides and corresponding angles. Okay? So it was year 512 BC. So there was a mathematician, his name was Thales. So he stated that if you have a two triangle whose angles are equal to each other, then both triangles are going to be similar to each other. So basically we call it equiangular triangle. What do we call it? Equiangular triangle. Equiangular triangle. What is the meaning of an equiangular triangle? So you can take one example. This is triangle ABC. Suppose this angle is, let's take 40 degree, 60 degree and 80 degree. Okay, you have another triangle, you can take another triangle PQR. In this case, this is also 40 degree, this is also 60 degree and this is also 80 degree. So basically we can call it equiangular triangle. So since angles are equal to each other, it means triangle ABC is going to be similar to triangle PQR since angles are equal to each other. If angles are equal to each other and they are similar, we can also write AB upon PQ is equals to BC upon QR is equals to AC upon PR. So if triangles are similar to each other, you can write this. Okay? So I hope you understood. So after some time, some people believe that this was a statement given by Thales led to give us a theorem called Thales theorem or basic proportionality theorem. So let's discuss about basic proportionality theorem. Okay, what is basic proportionality theorem? Because this is the first theorem we have to study in class 10. So basic proportionality theorem. Basic proportionality theorem. Some people also call it BPT. Basically, you are going to use BPT term most of the time. So let's prove it. So before that, I write a statement. What is BPT theorem basically? So you have to remember this. In any triangle, you have to write the theorem. In any triangle, if a line is drawn parallel to any side of a triangle, it divides other two sides in same proportion or ratio. Okay, so first of all I will give you an example, then after we will derive this statement or we will prove this theorem. Suppose you have a triangle ABC. If you are drawing a line DE, then we can write AD upon BD is equals to AE upon EC. So according to this theorem, since D is parallel to BC, you can write AD upon BD equals to AE upon EC. Similarly, you can take another example. Let's suppose this is P PQR, and I am going to draw line parallel to PQ. Let's say this is A and this is B. If AB is parallel to PQ, you can write RB upon PB is equals to RA upon QB. So basically this is the statement, and we will verify after some time how did we get this result. Okay, so basically if this is 2 and this is 4, then this is going to be 3 and this is going to be 6. So basically 4 by 2 is 2 and 6 by 3 is 2. So ratios are equal. So using DPT theorem, we can say that this line is parallel to this line. Okay, so let's prove this theorem. So basically, let's draw a triangle ABC. This is your triangle ABC, and we are going to draw a line parallel to DE, which is parallel to BC. So basically, what is given? Given that BC is parallel to DE, we have to prove that AB upon BD is equals to AE upon AC. This is what we have to prove. Okay, and so we have to do some construction. So let's do construction. The construction is join BE and DC. Join BE and DC, and also draw line EF and DG perpendicular to AB and AC. So this is the construction we need to do. After that, it is very easy to prove. So let's prove it. So what we have to do? We have to write area of triangle ADE. So what is the area of triangle? What is the any area of triangle? So basically half into base into height. So I am going to write half into what is base of this triangle? AD. Into what is height of the triangle? FE is equal to what is base of the triangle? AE into what is height of the triangle? DG. So half word cancel, and from there you can get AD without cancelling. Also you can write. So you can write AD is into FE is equal to AE into DG. So from there we can write AD upon AE is equals to DG upon FE. This is our first equation. Similarly, we can write area of triangle. We have not joined them, so let's join them. We can write area of triangle BD and E. What is area of triangle? Half. What is base? Base is BD, and what is height? Height is EF. Similarly, you can write area of triangle DE and C. What is the area? Half into base is what? EC into what is the height? So height is basically DG. We know that you have to remember one point from your class 9. What is that point? If you have two parallel lines, if you are drawing two triangles with the same base, area is going to be equal to each other. Okay, so you can see that DE and DC are parallel lines. DE is the base of triangle BDE and DEC. This is why area of both the triangle is going to be equal to each other. So I can write area of triangle BDE is equals to area of triangle DEC, because you can write Just to understand, you can write a statement here. These are triangles between same parallels, and it means both the triangles are between same parallels, so area is going to be equal to each other. So let's equate it. Half BD into EF is equals to half EC into DG. I can cancel this and this, and from there I can get DG upon EF, DG upon EF is equals to BD upon EC. This is second equation. Using 1 and 2, we can write, see, you can see very easily DG upon EF, here DG upon EF. So both are equal to each other. So I can write AD upon AE is equals to BD upon EC. Now bring this side, let's cross multiply basically BD and AE. So what are you going to get? We are going to get AD upon BD is equals to AE upon EC. This is what we have to prove. I hope you understood. Okay, so let me explain again. So basically, what is basic proportionality theorem? So this theorem says that in any triangle, if a line is drawn parallel to any side of the triangle, it will divide other two sides in the same ratio. Okay, so we have proved this theorem. For that, we have drawn a triangle ABC. Now we are drawing the last line parallel to BC, that is DE. And we have to prove that AD upon BD is AE upon EC. For that, we have done some construction. What is that? So we have joined DE and DC. Basically, we have joined the diagonals and we have drawn two perpendiculars, one on side AC and another on side AB. After that, we have written the area of triangle ADE, that is half base into height, and from there we got first equation, that is GD upon FE is AD by AE. Similarly, we can write area of triangle BDE and area of triangle EDC. Okay, so this is half base into height, half base into height. Now we can see that both the areas are in between the same parallels, that's why they are going to be equal to each other. So from there we have equated both the triangles and we got DG upon EF. Using this first and second, we can write that AD upon AE is equals to BD upon EC. From there we have cross multiplied and we got AD upon BD is equals to AE upon EC. AE upon EC. So this is the proof of Thales theorem or basic proportionality theorem. Let's take few examples to understand that. So any doubt? I hope you don't have any doubt. Okay, so let's move forward. So I'll take few examples so that it will be easy for us to understand more. So, if you have a triangle A, B, C, and this is D and this is D. So sometimes question is asked, this is 2 and this is 3, this is X and this is 5. And then ask D is parallel to BC, then what is X is equals to what? It is very simple to solve. You just have to write, since D is parallel to BC, you can write AD upon BD is equals to AE upon EC. So what are we going to get? We will get 2 by 3 is equals to X by 5. So I am going to get X equals to 10 by 3. This is the answer.